Today we're gonna investigate in
Coulomb's law.
Coulomb's law. But first, we need to introduce what is
Charge.
charge.
Charge has two types. One is positive and another one is negative. For the positive one, we will use proton as example. And for the negative one, we use electron.
Why are the charges defined in positive and negative? Simply because the scientists observed the behavior of the charged particles in a circuit.
Now I tell you why the scientists can use a circuit to define the charges. It is because they found out the light charge repels each other. So, because the electron is repelling with the negative terminal of the circuit, so it should be negative. Also, the scientists found out that the unlike charges attract with each other. They found out the electron is attracting to the positive terminal of a circuit, which means electrons should have a different charges with the positive terminal, which is negative charge.
Now we are going to prove the electrostatic force exists. As you could see, the electron is orbiting around the proton in a hydrogen atom. Given that the radius is 10 to the power negative 10, and we assume the centripetal force is all contributed by gravity. Using these two formula, and substitute the numbers, the velocity of the electron surrounding the proton is 1.06 times the 10 to the negative 14 meter per second, which means it takes around 60,000 seconds to perform one revolution. It's not reasonable, and then we proved a new force is also contributed to the centripetal force.
Now let us look why the Coulomb's law can be derived in our way. First, we need to look at our definition. First one is that the electrostatic forces is proportional to the two charges, and the second one is the inverse square law of the distance. So we can add a constant k inside, which k is equal to 1 over 4 pi epsilon naught. As to the epsilon naught, it is the permittivity of vacuum, or known as the electrical constant. It is a derived unit from two defined units, which is the permeability of vacuum and the speed of light. And the relation is that the epsilon naught is equal to 1 over permeability of vacuum mu naught c naught squared, which c naught is the speed of light. So the whole thing is epsilon naught equal to 1 over mu naught c naught squared. Now let us look at the equation again. Well, F equal to 1 over 4 pi epsilon naught q over r squared. The first thing we can see is the proportionality constant, 1 over 4 pi epsilon naught. Well, you see, our friend's epsilon naught has appeared again. Then we look at the terms which give the forces the nature. First is the inverse square law, and the second one it shows that these forces is proportional to the product of two charges, and this will be the electrostatic force. Try to compare the two formulae with the Newton's gravitational law. You'll find that in fact they are very similar. Both they have a constant, and then they are also subjected to the inverse square law, and finally they are also proportional to their quantity. One is charge, one is mass.
After careful measurements by Charles Coulomb, we found that the electric force decreases with the square of the distance between charges, like gravity does.
He named the law Coulomb's law after himself. It is applicable for electrostatic forces only.
In the equation, the two Q's represent different values of charges respectively. R is the distance between the charges, and the 1 over 4 pi epsilon naught, also known as K, is a constant. The unit of charges is the coulomb. After substituting the numbers and the calculation, we know that the velocity is 1.6 times 10 to the power 6 meter per second, which is reasonable. And we know that Coulomb's law is correct.